Hello and welcome to a lesson on differentiation and integration. This lesson follows on from the lessons on differentiating and integrating polynomial functions. And this time we'll be looking at differentiating and integrating rational powers of x. To begin then, let's remind ourselves of the standard formulae for differentiating and integrating powers of x. If we differentiate ax to the power n, then the power comes to the front and is multiplied by the constant that's already there, and the power is decreased by 1. If we're integrating ax to the power n, then the power is increased by 1 and we divide the term by the new power. We also get a constant of integration. Now it turns out that these formulae are not just true for polynomials, they're true for any rational powers of x, so we can have negative powers and we can have fractional powers. The only exception is we're not allowed to have n equal to minus 1. That would be the integral of 1 over x, and it would lead to us trying to divide by 0, because minus 1 plus 1 would be 0. And you'll find out later in the A-level course that the integral of 1 over x is actually a function called log x. However, back to differentiating and integrating rational powers of x. We'll look at 8 examples, 4 of each. Example 1. Y equals 3 root x minus 5 over x. And we're going to find dy by dx and d2y by dx squared. So we're going to differentiate twice. The first thing we do is we rewrite the expression, getting rid of the square root sign and getting rid of the denominator. So we write y equals 3x to the power half, because x to the power half is the same as root x, minus 5x to the power minus 1. And now we're in a position to apply our rule. Dy by dx is equal to a half times 3, which is 3 over 2, multiplied by x to the power, well, 1 less than a half is minus a half. Moving on, differentiate minus 5x to minus 1. The minus 1 comes to the front and is multiplied by the minus 5, so we get plus 5. And lowering the power by 1, we end up with x to the minus 2. Now we can leave the answer like that, that would get full marks in an exam. Or we could rewrite it in a form similar to the form they gave us the question, and that would be 3 over 2 root x, because x to the power minus a half is 1 over x to the half, which is 1 over root x, plus 5 over x squared, because x to the minus 2 is 1 over x squared. Now if we're going to differentiate again, we need it back in this form here. So let me write that again. Dy by dx is equal to 3 over 2 x to the power minus a half plus 5 times x to the power minus 2. d2y by dx squared, differentiating again. Now we have minus a half multiplied by 3 over 2. So that's minus 3/4. X to the power, and 1 less than minus a half is minus 1/2, which we write as minus 3 over 2. Next term, minus 2 times plus 5 is minus 10. And 1 less than minus 2 is minus 3, so it becomes x to the power minus 3. And there's really no point in trying to write that in any other format, because x to the power minus 3 over 2 doesn't get any more friendly if we put it in a denominator. So what can we see is happening? Well, if we differentiate a negative power, notice how we get a sign change in the term. Both of these have gone from positive terms to negative terms because the powers we were differentiating were negative. And that concludes example 1. Example 2. Y equals x to the power a quarter plus 1 over x cubed. We're going to differentiate twice again. The first term is already in the right form, x to the power a quarter, but I want to rewrite this one as x to the power minus 3. So y is equal to x to the power a quarter plus x to the power minus 3. Differentiate, dy by dx is equal to, the quarter comes to the front, so we get 1 quarter x to the power, now 1 less than a quarter is minus 3 quarters. Take off a quarter, we're at 0, still have to take off another 3 quarters, so it's x to the power minus 3 quarters. Differentiate the second term, the minus 3 comes to the front, and we get minus 3 x to the power minus 4. And that's one you've got to be careful with. A quarter, subtract 1 is minus 3 quarters. Often students seem to put minus a quarter or minus 5 over 4. So think carefully when you've got a fraction close to 0 when you subtract 1 from it. Now let's find the second differential, d2y by dx squared. So differentiating here, minus 3 quarters comes to the front and is multiplied by a quarter, and that gives minus 3/16. X to the power, now 1 less than minus 3 quarters is minus 7 over 4. We need to subtract another 4 quarters. And the second term, minus 4 times minus 3 will be plus 12. And 1 less than minus 4 is minus 5. So that's the answer. d2y by dx squared is minus 3/16 x to the minus 7 over 4 plus 12x to the minus 5. Moving on now to example 3. Find dy by dx when x equals 16. So we're only differentiating once this time, but then we're going to substitute a value of x into our differential. First of all, we rewrite y equals, instead of root x, x to the power a half. Instead of plus 1 over x squared, plus x to the power minus 2. Differentiate, dy by dx is equal to, the half comes to the front, x to the power 1 less than a half is minus a half. Differentiate plus x to the minus 2, the minus 2 comes to the front, and we end up with minus 2x to the power minus 3. 1 less than minus 2 being minus 3. And I'll rewrite that as 1 over 2 root x. X to the minus a half is 1 over x to the half, which is 1 over root x. Minus 2 over x cubed. Now, although I said you could leave the answer like that, and you can, it's easier to substitute a value in when it's in this form here. So that's why I've rewritten it. So I'm now going to say, when x equals 16, dy by dx is equal to 1 over 2 root 16 minus 2 over 16 cubed. And that's equal to 1 over 2 times the square root of 16. Square root of 16 is 4, so 2 4s are 8. Minus 2 over 16 cubed, and 16 cubed is 4096. And if we stick that in a calculator in fraction mode, we can get an exact answer. It comes to 255 over 2048. And that concludes example 3. Example 4. Find dy by dx when x is 9. Y equals x to the power 3 over 2 minus x to the half. So it's in the right format for differentiating. Dy by dx is equal to, the 3 over 2 comes to the front, lower the power by 1, and 1 less than 3 over 2 is a half. 1 less than 1.5 is a half. Next, the half comes to the front, still got the negative sign, and it's x to the power minus a half. And we can rewrite that as 3 over 2 root x minus 1 over 2 root x. Again, x to the minus a half is 1 over root x. And that's an easier version to substitute into, so when x equals 9, dy by dx is equal to 3 over 2 times the square root of 9 minus 1 over 2 times the square root of 9. So that gives us root 9 is 3, 3 3s are 9, so that's 9 over 2 minus 1 over root 9 is 3, 2 3s are 6. Put that on a common denominator of 6 and we get 27 over 6 minus 1 over 6, which is 26 over 6, or as a mixed number, 4 1/3. And that concludes our 4 examples on differentiation. We'll now go on to look at integration. Example 5. Evaluate the indefinite integral, the square root of x plus 1 over root x. The first thing we do, rather like when we were differentiating, is we write it in a form that's easy to integrate. So instead of root x, we write x to the power a half. And instead of plus 1 over root x, we write x to the power minus a half. And now we're ready to integrate. If we integrate x to the half, we raise the power by 1 and we get x to the 3 over 2 divided by the new power. Integrate x to the minus a half and we raise the power to plus a half, 1 more than minus a half, and divide by the new power. And we have a constant of integration. Now what I need to do now is divide by these fractions, and to divide by a fraction you turn upside down and multiply. So this becomes 2/3 x to the power 3 over 2 plus 2 over 1, which I can just write as 2, x to the power a half, plus the constant of integration. Moving on to example 6. Evaluate the indefinite integral 3 over x squared minus 2 over x cubed. Rewrite as the integral of 3x to the power minus 2 minus 2x to the power minus 3. So when we integrate 3x to the minus 2, we get 3x to the minus 1, raising the power, divide by the new power, minus 1. Minus 2x to the power 1 more than minus 3 is minus 2, divide by the new power, minus 2, plus a constant of integration. Now then, 3 divided by minus 1 is minus 3, so that's minus 3x to the power minus 1. Minus 2 divided by minus 2 is plus 1, so that's plus x to the power minus 2, plus a constant. Now we can stop there, or we can rewrite it as minus 3 over x plus 1 over x squared plus a constant. We'll now go on to look at 2 definite integrals, where we have to substitute values once we've integrated. So example 7, integrate between the limits of 1 and 8, x to the minus 2/3 plus 1 over x squared. Rewrite to start with, 1 and 8, x to the minus 2/3 in the right format, but this second term needs to be rewritten as x to the minus 2. Now we integrate, Add 1 to the power. Minus 2/3 plus 1 is plus 1/3. So it's x to the power plus 1/3. Divide by the new power. Plus x to the power, raise the power by 1, we get minus 1. Divide by the new power. No constant of integration when we do indefinite integration. We're going to substitute in the values of 8 and 1. But let's tidy up what's in the bracket to start with. Divide by 1/3 is the same as multiplying by 3, so I get 3x to the power 1/3. And this becomes plus divided by minus is a minus, 1 divided by 1 is 1, so that becomes minus x to the minus 1, which I'll write as minus 1 over x. Now we get two brackets. First one evaluated with x is 8. 3 times 8 to the power 1/3, the cubic root of 8, minus 1 over 8. Minus, the second bracket, will be 3 times 1 to the power 1/3, the cubic root of 1, minus 1 over 1. Cubic root of 8 is 2, 3 2s is 6, so we've got 6 minus 1/8, minus cubic root of 1 is 1, 3 times 1 is 3, and that's just minus 1. So we've got 6 minus 1/8, and 3 minus 1 is 2, and so we're subtracting 2, which is equal to 6 minus 2 is 4, 4 minus 1/8, final answer 3 7/8. And that concludes example 7. And now our final example, example 8. Integrate 1 over x cubed minus root x between the limits of 1 and 4. First thing to do, rewrite it in a form that's easy to integrate. So 1 over x cubed we write as x to the minus 3, and minus root x becomes minus x to the power 1/2. Now perform the integration. Integrate x to the minus 3, and we get x to the power minus 2, raising the power by 1, divide by the new power minus 2. Integrate minus x to the 1/2, and we get minus x to the 3 over 2, 1 more than the 1/2, divide by the new power 3 over 2. And the limits 1 and 4. Before we substitute in, let's tidy up the bracket. 1 divided by minus 2 is minus 1/2, and we may as well take the x to the minus 2 back downstairs and become minus 1 over 2x squared. Minus, to divide by 3 over 2 we multiply by 2/3, so it's minus 2/3 x to the power 3 over 2. Now we can substitute in the values. First bracket, putting in the 4, we'll get minus 1 over 2 multiplied by 4 squared, minus 2/3 times 4 to the power 3 over 2. Minus the bracket with 1 substituted in, and we get minus 1/2 because 1 squared is just 1, and we get minus 2/3 because 1 to the power 3 over 2 is just 1. What does that give us? The first bracket, we've got 4 squared 16 times 2 is 32, so we've got minus 1/32 at the front. 4 to the power 3 over 2. The bottom one gives you the root of 4, square root of 4 is 2, and the top one gives you the power, 2 cubed is 8. So it's 8 times 2/3, which is 16/3, and it's negative. And this second bracket, we've got minus 1/2, minus 2/3. Let's take off the brackets, and we get minus 1/32, minus 16 over 3. Minus a minus is a plus, so that's plus 1/2. Minus and minus is a plus, so that's plus 2/3. Now a half is 16 30-seconds, so 16 30-seconds minus 1 30-second is 15 30-seconds. And minus 16/3 plus 2/3 is minus 14/3. Now we need to put this on a common denominator of 96, and if we do that on a calculator, the answer comes to minus 4 and 19 36ths. Questions often asked for the exact answer, and so there's no need to go into decimals. We can give it as a mixed number like that. That concludes this lesson on differentiation and integration of rational powers of x. You need lots of practice at these techniques, and you'll now find 2 exercises, exercise A and exercise B, 10 questions on differentiation and 10 questions on integration.